What's up my friend? So in this video we are going to see how we can implement our own whoami command. So basically this command is just do one thing. It just show you the current user in the system. So for example, if we did whoami like this, the current user is assembly boy. And for example, if we went to the root and we need to enter the password and we did whoami like this, the current user is the root. Alright, so let's get out from the root user like this and clear, and that's it. We're going to add two flags on this command. So we're going to add the -s flag and the minus or the -h flag. So the -s sorry will show you the current shell of this user, and the -h will show you the current home of this user. I know in the real command there is no -h or -h flag, but we are going to add it by ourselves. Alright, so let's get started. We are going to go to the C version like this, and we are going to do clear like this, and ls we don't have no files, so main.c, not ASM yet. Okay, good. Now our important header file, which is what? Which is sorry, let's do like this, bro, come on, like this, include our stdio.h. Alright, of course we need our int main with the two parameters, which is argument counter int argc and char pointer av, like this. Alright, and finally return 0. Good. Alright, basically the command doesn't need any argument, but because we are going to add the -s and the -h flag, so we need the arguments. Alright, good. Now let's start. Basically, to get the current user and print it in the stdout, we need in the first to get the user ID. So we're going to go right here, and this function no, in C. So we have get user ID in C. So simply this get user ID, it bring you the user ID of the current user using this function, which is get user ID. The return value is from type unsigned, I guess unsigned id-t. That's it. So we're going just to copy this function like this, and uid-t like this. For example, user ID like this. Alright, equal this function, and it takes no parameters. Alright, so to call this function we need the unit std, and for this data type we need this header file, which is sys/types.h. so we need to copy these two header files and copy them, paste them right here. We're going just to do a command, this for get user ID, and this for the user the uid-t type. Good. And also let's add the comments right here. Okay, this is for printf. Okay, good. Now let's try to print this user ID. So we have double quotes like this, double quotes and %d and the user ID. Good. Now compile and run. As you can see, our user ID is 1000, right? And for example, if we went to the root user, for example like this, and we did dot I guess, yep, the home and the ASM boy, and we went and we did Linux command and -whoami, whoami, and we went to the C version and we run this. We are going to see that the ID of the root is 0. So this function will give you the current ID of the current user in the system. Alright, now let's get out from the root user, exit like this and clear. And if we run it again, for example like this, we are going to get 1000. So this 1000 is the ID of the assembly boy user. Okay, let's continue. Now we have the user ID. Okay, we want to print the name of this user ID. Good. So we need another function which is get print user ID. Alright, so basically this function just do one thing. This function is used to retrieve information about a user from the system user database, which is etc-passw or similar resources like I really don't know this NIS or this LDAP. I don't know. If you know it, type it in the comments. Alright, so basically this function, it just fill this struct. Alright, and I have a picture of this struct from ChatGPT. As you can see, this is our struct. So when we did this function, it take the user ID and take all the information about this user, the name, the passw, the user ID, the directory, the shell, and our work is to first thing print the name, and then if he did the minus s will print the shell, and also if he did minus shell, we are going to print also the current shell of this user, and also if he did minus h, we are going to print the directory, and if he did like minus home, we are going to print the directory also. Alright, so that's it. As you can see, we run the function and it fills this struct. Okay, now we are going to create a struct. For example, let's name it the user info, for example. No, struct passw and a pointer because it will user info like this, and the user info which will equal the function. So this function like this, we are going to print it, copy it, paste it right here, sorry, and it takes the user ID. So we are going to copy this user ID and paste it right here. Good. Now as you can see, we can do just printf and percentage, let's say percentage s, I guess, because we are going to print the name, and pw we are going to print, as we know, we are going to print the name. So pw dash name. Alright, so we have here pw dash name. Good. Now let's do gcc. Good. Undeclared first use in this function. Alright, so where is the problem? So here is the problem. We need to take this struct, and from it we need to get this pw name. Just not just print the pw name. This is my fault. Okay, so we need to do user dash info and like this. Good. Now let's see. Let's do gcc and let's run it. As you can see, assembly boy. Now let's go to sudo -i, and if we did and home and linux command, yep, and linux command like this, and dash whoami, and if we want to see version clear, and if we run this binary like this, we are going to see that the current user is root. Good. Now let's exit and continue. Now it's so simple. We did what the real whoami do, which is just printing the current user in the system. But we're going to add something like minus s and minus h, as we said. Right? So we're going to go right here and do something. We're going to do if like this, if let's say alright, so if the argument counter is greater than 1, alright, Then we are going to do if in comparison if the AV of index 1 is equal to what? No, I need str comparison here. I need str comparison, and we need to compare the AV with dash dash minus h. Is it equal to 0? Or let's do or str comparison the AV of index 1 is equal to minus whom is equal to 0. Is the comparison is equal to 0? If yes, then simply we are going just to set int h flag equal to 0 and int s flag equal also to 0 in the beginning. Then we are going to do h flag equal to 1. Good. Then the same comparison we are going to do else if right here, and the same thing. Okay, so let's close this and let's do str comparison of AV of index 1 and is it equal to dash dash minus s. Is the comparison is equal to 0 or not? Then or str comparison of AV of index 1 is it equal to minus shell. Is it equal to 0 like this? We need to close this bracket. Now let's make it like this. Let's make it a little bit bigger. Good, and let's close it. What? Where is the problem? Where is the problem? Yup. We need here to close it like this. Good. Alright. Then we are going to set the s flag to 1. That's it. To 1. And here basically we need to print the user info. Yep. What we need to do, we need to print the user info. Then we are going to do, for example, 2 points. I don't know, just a space like this, and we are going to do if condition here. So if the s flag, the h flag is equal to 1, then we are going to do printf and double quotes and 2 points. Then we are going to do percentage s, and we are going to do the user info struct, and we are going to access what? Going to access the pw directory, pw dash directory. Good. And else, let's do else if, let's do some space, and here also some space. Else if the flag, the s flag is equal to 1, then we are going to do the same thing, and we are going to do like this, print the shell, pw shell. Alright, now let's do gcc. Yep, I need string.h include string.h, another comment. Alright, for the str comparison. Good. Now gcc and run. Good. Minus h, we have the home directory, minus home. Good. Dash shell. Good, our shell. Then dash s, the same thing. Good. Now let's go to sudo. Now let's go to the root user. Now let's go to the root, so sudo dash I let's go to home, good, and Linux command, and dash whoami, then C version, then let's run it. Okay, the current user is the root. If we did -h, as we can see, the home directory is slash root. If we did dash home, we are going to see the same thing. Dash shell, this is the shell of the root. Dash s, good. If we enter a flag, another flag, for example -p, it will just print the current user. Now let's go to our main.c. So this is our this is our C code to print to implement the whoami command and add two flags, which is the -h and the -s, to print the home directory of the current user and print the shell, the current shell of the current user. Now the big boss, assembly. Alright, let's go to our assembly folder. Alright, now we're going to create our main.asm. So here we have section dot data like this, and section dot text, global start, and our start label like this, and also our program end label. So here we have move rx16, the exit syscall number, good, move rdi0, and syscall, good. Now we need to set our variables or our flags. So we have home short define byte dash home and null terminator. We have here home long define byte dash home and the null terminator, good. Then we have the shell long. Let's start with shell short like this, define byte dash s null terminator, then shell let's say shell long define byte dash shell and 0, good. Now let's start. We need to get the argument counter, so move in the RDI because we're going to create our main function, and the check flag function, good. Now here we have move RDI. We are going to take the argument counter. As we said in the start of the program, the ISP is pointing to the argument counter. Get the arg C from the stack. Then here we are going to load in the ISI the ISP plus 16. ISP plus 16. Alright, so the ISP is pointing to the argument counter, so ISP plus 8 will give us the first argument, then ISP plus 16 will give us the second argument, because we don't need to check the name of the program, so we're going to skip it. Alright, get the second argument, the flag, good. Now we're going to do an if condition, I guess. No? I guess what we need to do, we need alright, we need to compare the RDI with 1. If it is equal to 1, then we are going to jump directly, we are going to call directly the main. Or let's what we have here. So here, if the RDI is equal just to 1, we need just to jump to get user and nothing else. Alright, else we need what we need to do, compare RDI with 1. If it is equal to 1, then we need to jump directly, jump equal main path. So this main path will call the main function, then after it we'll jump to program end like this. Else we are going to call check flag function. Alright, this is the logic. If the RDI is equal to 1, then we have just the name of the program. So we're going to directly jump to the main path. Okay, good. Else, if the RDI is greater than 1, so we have the flags. Then we're going to go to the check flag, right? And after the check flag, we'll continue. Then we're going to... there is a problem right here, bro. We will do this condition inside the main function, bro. No, inside the main function right here. So we're going to do main function. So we're going to do here the main function. Now we're going to call our main function, so call main. Now we're going to call the main function, so we have here call main, and after it we're going to jump to the program end. Good. Here we have, we're going to do command main function. Good. And copy this and paste it right here. Good. Main, then push RBP, move what is inside the RSP in the RBP. Okay, like this. Then subtract the RSP with, we need, I guess, 48 bytes, I guess. Okay, and here we have main end. We are going to do add the RSP, the same number, pop RBP, and return. Good. Now we need to save the argument counter, the argument vector, and 2 flags. Alright, we are going to do move in the RBP -8 the argument counter, saving the argument, let's say just the argc. Alright, argc, and we are going to move in the RBP -16 the argument vector, the RSI, saving the argv. Good. Then we are going to save in the RBP -32. Yep. No, 24. We are going to save just 0. Alright. Then in the RBP -32 also just 0. Why I did here 0? Because we need to do a comment right here and know the offset of the home flag and also the offset of the check the shell flag. All right, so here we have home flag, and here we have the shell flag. Good. Let's do an alignment right here. Good. Now set the now here we need to do a comparison. We're going to compare the RDI with 1. If it's equal to 1, then we're going to jump directly where to get user function. Right, not a function, just a like a label. Okay, get user. Else, if the RDI is equal is greater than 1, so we have parameters, so we have argument, so we have the flags. Then we are going to do set the argument for the check flag function. Good. Now we need to move in the RDI what? We need to move what? The RBP -8. The argc. And we are going to move in the RSI what? We need to move the RBP -16, which is the argv. Good. Then we need to move in the RTX what? The RBP -24, which is what? Which is the home flag. Alright, let's do a simple alignment right here. Then we need to move in the RCX what? The RBP -32, which is what? Which is, as we said, which is the shell flag like this. Then we call our check flag function. Good. Then directly it will go to the get user. All right, now let's continue with the get user, then the check flag. We did the check flag function in the video of echo and a lot of videos. Okay, so it's so simple. All right, here we need to get the user. we are going to follow the same steps that we did in the get user in the C language. So we're going to go right here and go to our C version and do cut main.c. okay, and we're going to do like this and like this. As you can see, first thing what we did, we get the user ID. So let's search for this function. We have here get user ID in assembly. So there's a syscall for this function, which is 102, right? So what we need to do, we need to do like this. So we need to do get, sorry, not here but here, just a command, get user ID syscall 102. So I'm going to move in the rx 102 number syscall number. Good. Then just that's it, syscall. All right, good. Then what we need to do now, we need to do the function of get print user ID. All right, we don't have a syscall for this, we have just a function. So we are going to do a C function in assembly. All right, so what we need to do, we need to do a extern. So here we have, we're going to do extern print user ID. Okay, then we have here extern what, extern str comparison also, and then extern strlen. We need these three functions. All right, now we're going to do call get print user ID function. Good. We need to pass the user ID to this function. So move RDI what is inside the RX, because the RX is the return value of the syscall. Then we are just going to do call this function. So let's copy it again and paste it right here. The return value, okay, so here the return value what, it's a struct, and the rx will point to the first element of this struct. As we can see, here is how is it the struct in assembly. It's the same struct, but just here in assembly we need the offset. Okay, so now the rx will point to the first element, which is the name of this user. All right, let's continue. So the rx will point to the user, to the first element of the struct. Bro, come on. Struct like this. pw dash name. Good. Now we're going to save the pointer in the rbx. Okay, then we're going to do print the name, the username. Okay, now we're going to move in the RDI, which is inside the RBX, because the RBX is just the address of the first element. We need the actual string, so we need to dereference this address. All right, dereferencing the address to get the actual string. Good. Username, for example. Okay, good. Then we are going to call the strlen function. Then the return value will be in the rx, so we need to move it from the rx to the rdx. All right, for the right syscall. All right, then here we are just going to do the right syscall. Good. So move rx1, move rdi1, move rdi1, move rsi what is inside the rbx. All right, then rdx has already len, then syscall. Good. Now what we need to do, that's it. Okay, call check flag. Okay, now let's do NASM. Yep, we have a lot of problem in the line 36. In the line 36, yep, here let's just say word and here also word. Here we need to specify the length or the size of the data that we want to move from our code to the stack. Alright, good. Now NASM, okay, check flag not defined. Okay, this is the check flag. It will just do like this. Now we need to do something, because here we have an external functions, so we need to load this line of code, this command to compile our NASM. Okay, here first thing we need this flag for no position independent executable, so we need a static addresses. Then here we have no start file, because the C language it will add its own start file and we are at the start label, and already we have our own start label, so it will be a conflict. All right, then we have the -ls to link our C functions. All right, then here we have minus my whoami, and we are going just to run it. Okay, assembly board. This is the current user. If we went, for example, to the root user, the password, and cd home, the user, and Linux command, and -whoami, and ASM version, and if we run it, we are going to see that the current user is the root. Good. Let's continue. Now the simple thing that is left is just to handle the flags. Right, now what we need to do, we need to set the stack frame of this check flag function. Alright, now we're going to do push RBP, then move in the RBP the value of the RSP, then subtract the RSP by, I guess we need here 48. Good. Now we need to take the argument and save them in the stack frame of this function. So we're going just to do a copy of this and paste it right here to be a reference for us. We're going to move in the RBP -8. We're going to move the argument counter, the argc. Good, as we can see here. Then the RDI, okay, which is the argument counter. Then we are going to move in the RBP -16. We are going to move the RSI, which is the argument vector, as we can see here, the argv. Good. Let's do a little bit of alignments right here. Good, and here also. Okay, good. Then we are going to move in the RBP -24. What we are going to move the RSI, no, the RDX. Just do a space, the RDX, which is the home flag, like this. Then we are going to move in the RBP -32. What we are going to move the RCX, which is the shell flag. Very good. Now let's delete this and let's continue. Okay, here we need a check loop. We are going to loop, and we need to set some things. We need to set, for example, we're going to move in, for example, the R14. We're going to move the argument counter to be a reference for us. So RBP -8, saving the argc in R14 register. Good. Then we are going to move, for example, in the R10, for example, we are going to move 0 for the loop. I guess, yep, 0, it's good. Not 0, I guess 1. Yep, not 1. Here we are skipping the argument, the name of the program. So here, if we start from 0, I guess it will be a problem. Or not. Let's start from 1, okay? Then here we are going to compare the R10 with the R14. Like this, R14, jump equal to check end. Good. Then simply we are going to move in the RDI. What is here? We need to move in the R12, the argv. So RBP -16. Okay, saving the argv in R12. very good. All right, now we need to say like this, just like this, R12. Good. And move in the RSI watch, move in the RSI this short flag. Good. Then we call our SR comparison function, SR comparison, and we compare the RX with 0. If it is equal to 0, then we need to jump equal to where set short home flag. Good. Now let's do another thing, which is move in the RDI the R12 and move in the RSI watch the home long. Okay, then we need to call SR comparison. If the return value is equal to 0, then jump equal to set home long flag. Then we need also do move RDI R12, then move RSI watch short shell. Okay, then let's do something like this, a flag command like this, -h, and here minus home. Okay, and here let's continue. So call SR comparison. If the return value is equal to 0, then jump equal, let's go down here, set shell short flag. Good. Then we have the last condition, move in the RDI which is inside the R12, then move in the RSI watch the long shell like this. Let's remove this and let's continue. Then we need to call our SR comparison, then compare the RX with 0, then jump equal to set shell long flag. Good. Let's do a comment here, double quotes -s, and here double quotes minus shell. Good. Now what we are doing, we are taking the argument, the second argument, which is saved in the R12, and we are dereferencing. So we are taking the string and pass in the RDI. Then we are taking the home short and pass it in the RSI and do a comparison. If yes, we are going to set the home short flag to 1. And here there's a problem. If you know where is the problem, please tell me in the comments. Here we are passing the actual variable. All right, so if we did move 1 in the RPP -24, it will just be 1 in this stack frame. We need to edit this variable right here in the main function. So here we need just to pass what? We need to pass the address. So we need to load the effective address of this place into this register. Then here we can just do like this, do this command and do. Okay, then now we need to take the actual address of the RPP -24, the address of what? Of the home flag, and we need what? We need to do move in the R9, so we need to dereference this address and add and put 1, then increase what? Increase the R10 by 1, then that's it. We need to jump to check end, which is this check end. Okay, let's continue. Let's do add RSP 48, then pop the RBP and return. Alright, and we are going to do here jump to check and like this. Good. Now let's do copy this. No, let's not copy it. Let's just do set home long flag. What I am doing here, bro? There's something here. Why I am doing 4 different labels here? I just need to copy this and paste it right here, because it will do the same thing. So just copy it like this. alright, and copy it also right here, because it do the same thing, they are setting the same variable, alright. And here just set shell flag, and here the same thing. Why I did 5 different labels, I don't know why. Okay, like this. Move in the R9 watch the RBP minus 32, which is, sorry, minus 32, which is the shell flag. Good. Then we are going to dereference this R9 and add, put in it 1, then increase the R10. Why I need to increase the R10, bro? What is this stupidity? Okay, just jump to check end. Okay, like this. Good. Here in the first thing, he will compare the R12 with the home short. If it is not equal to it, he will go to this second condition, third condition, fourth condition. If no one is equal to the flag, then we are going to jump directly to check end. Good. Now let's see, let's do some space right here, and let's continue. And here we are going to do a logic. So here in the get user, we need to continue here, we need to check. Okay, so we are going to move, for example, in the R14 we are going to move what is inside the RBP minus 24, the home flag, and we are going to compare the R14 with 1. Is it equal to 1? If it is equal to 1, then jump equal to print home. Else we are going to move also in the R14 the RBP minus 32, and shell flag. Then compare R14 with 1. If it is equal to 1, then jump equal to print shell. Alright, so here you have print home. So print home label, we need to take the RBX is equal to 1, so we need to take the move what? Okay, so move what is inside the RBX in the R12, for example. Okay, then add R12 by what? By 32, as you can see here. So just add 32 like this, then move what is inside the R12, okay, in the RDI, then call strlen, then move the return value from the strlen to the RDX, then move RX. Let's do some comments here. Write syscall, move RX1, move RDI1, move RSI, which is inside the R12. We're going to dereference this address, so R12. Good. Then syscall, and directly jump to main end, then here we're going to do the same thing, just let's copy it, and here we have print shell. We are going to add what? 14 like this. Good. Alright, now let's compile, and I truly know there is a lot of problems, as I said. Okay, in the line 151. Good, let's start. In the line 151, we have move in the RSI the short shell. Okay, let's copy these variables like this, and let's paste them right here. Okay, good. Right here, and let's see, we have home short is equal to home short. We have shell short, not short shell. Right, so just what I'm going to do like this. Good. Then we have here shell long, not long shell. Good. Let's say move this reference. Good. Now let's save NASM. We have operation size not specified in the line 168. Let's continue. 168. Yep, here just move 1 byte, and here move 1 byte in this address. Okay, NASM GCC. Good, and let's run it. As you can see, it gives us the assembly boy. Okay, -h. Okay, but the problem is when I did just the name of the program, it should give me just the username. But let's say, for example, minus shell, it gives us the shell, and if I did dash home, it gives us the home. But just the name of the program, it should just give me the name of the user. Alright, let's see where is the problem. So here we are doing call the main, and here we are doing a comparison. If the RDI is equal to user is equal to 1, then here we are just going to jump to get user, and the get user do its function. It take the user ID, print the user ID, and print the username. But here is the problem. There is no jump, so we actually get right here into these flags, and it's continue printing the home and printing the shell. Right, so this is the problem. And I will give you another thing. Here, for example, either if the RPP-24 is empty, is equal to 0, it will go and check if the RPP-32 is equal to 0 or not, and there is no else condition, so directly it will go to the print home and print shell. So here simply we just need to do what? We just need to do jump to main end like this, and let's do NASM again, GCC. As you can see, it's work right well. Minus s minus h minus home minus shell. Good. Now let's do GDB to see the addresses in the real world. GDB. Okay, let's break at the main. Let's do run, for example, -h. Okay, let's continue. Here we have saving in the RPP -h. Okay, good. Here is we have the comparison. The comparison is false, so it will set the parameters for this check flag function. Alright, good. As you can see, we are moving the RPP -h, which is the argument counter in the RDI. So the RDI now is equal to 2. Now the ISI will point to the second argument. As you can see here, the ISI now is pointing right here. Now the RDX will have the address of this variable. As you can see, here is the RDX. Look, now he is pointing to this place. Good. Now the RDX the same thing. He will point to the same place. Good. Now let's continue SI inside the check flag function. Good. As you can see, these two places are pointed in the same to the variables. Alright, taking the others of the variables. Good. Now let's continue. The R14 is equal to 2, then the R10, then the R12 now is equal to the second argument, and here we have a comparison. Now as you can see, the RDI is equal to -h, and the string is equal also to the -h, so the comparison will be true. As you can see here, the RX is equal to 0, then it will go to set home flag. We are taking the address and saving in the R9, then setting this address to 1. As you can see, now it's equal to 1. Okay, let's continue. If you want, for example, to set this whole address to 1, we can do something like this. For example, let's go down here. Let's continue, and we can do word or keyword. Let's just say word, and here word, and let's do NASM GCC shell home. Alright, we have a problem in the home. Alright, let's see where is the problem. Run -h. Okay, let's continue. Let's go to check flag. Let's continue. Good. Okay, as you can see now it's equal to 1. Good. There is a problem right here. It's equal to 401. Let's say trying to do keyword. Keyword like this, Q, and here also Q, C, and dash H. Okay, now it's working. Let's continue. Let's do for example break at the main and run -h. Let's go to the function as flag like this, and let's continue. Okay, as we can see, we set the whole address to 1. Okay, so the keyword is equal to 8 bytes, so we set this all block of memory to 1. Okay, now if we went to the main function, let's skip, and when he take the address in the R14, he will get that the R14 is equal to 1. Okay, and the condition will be true. Okay, now let's do exit and clear. Okay, now let's do our last test. -h, -s, good, -shell, -home, good. Now let's go to the root. Okay, so let's do sudo -i, good, and punch home asmboy Linux command -whoami cd -whoami, good, asm version, and let's run. The current user is the root -h. The home directory is root/root. The shell is zsh. Okay, --shell --home. Good. Now let's do exit and main.asm, and here we have our code. So let's do here also vim clear. No, not you. Vim main.c. Alright, as we can see, this is our C code and this is our assembly code. So see you in the next video where we are going to implement another Linux command or another reverse engineering video. Take care, peace.